All right, Algebra 2, let's continue with Unit 8. So we're on Unit 8.2 today. We're going to look at angles in degrees. So some of this is, again, going to be review from geometry. So in graphing angles, and again, we use that symbol theta to represent an angle. We're going to graph on the coordinate plane, that's the xy axis, and we're going to start in quadrant 1. And so an angle is made up of two rays, and they intersect at a vertex angle. And that vertex, or the vertex point, and so that point that the two rays come together, we're going to lay that on the point 0, 0 on the xy axis. Now there's two rays, like I said, and one ray is called the initial side. That's going to be on the positive x-axis side, and that side's never going to move. But what we're going to do is take the terminal side, the other ray, and that one's going to rotate. And we can rotate that in a clockwise direction or in a counterclockwise direction. And as that terminal side opens, it creates a bigger and bigger angle. Right? And so that's called standard position. So when we want to graph a positive angle, we're going to put that initial side right on the positive x-axis side. And that vertex point will be at 0, 0. And then we're just going to take that terminal side, and then we can rotate it. Okay, we're going to go in the counterclockwise direction. And what we're going to do is put that arrow in the middle, and this shows the angle of rotation, which way that we're rotating to get a positive angle. So for this angle, we could say that is a positive, 50-degree angle, 45-degree angle, something close to that. But it's positive because of the arrow that we showed in red, which direction that we were going. All right. Now negative angles are just going to go in the opposite direction. So again, we'll start on the initial side, and now we're going to take and rotate. Let's say we'll put the terminal side over here. And then we're going to rotate it in this direction, right? So this is the clockwise direction. And so this would be a negative angle. And so we could say this is about a negative 120-degree angle or so. So we want to make sure that we put it as a negative angle because of the direction of rotation. All right, each quadrant divides angles into 90-degree sections. So if you remember from Algebra 1, this is Quadrant 1, and we go in the counterclockwise to name them. Quadrant 2, Quadrant 3, and then Quadrant 4. Typically we use Roman numerals, but if you didn't, it's not that big of a deal. Now our angles, again, they're starting right here. And so let's say both the terminal side and the initial side and terminal side were directly, on top of each other. Okay, so they're right on top of each other. So this is going to produce a 0-degree angle. And then as we rotate in the counterclockwise direction, okay, now we'll be at 90 degrees up here. And then we keep rotating. We'll be at 180 degrees directly across from 0. And then we'll be at 270 degrees across from 90. And then we rotate again. And as soon as we're back on 0 again, we can say that we've done one complete revolution, and we can say that's 360 degrees. All right, and then we can keep going. So we can rotate this more and more times, as often as we need to. So you can have more than a 360-degree angle. All right, now if you go in the negative direction, then where 270 is, this would be a negative 90-degree angle. Okay, then we would be at a negative 180-degree angle if we keep rotating in the negative direction. we'd be at negative 270 degrees, and then negative 360 degrees. So again, it all depends on which angle or direction that you're rotating. All right, so let's go ahead and graph each of these in standard position. So we can use the 90 degrees sections to help us out. So 135, okay, so we're gonna go ahead and start right here. This is our initial side right here. And then 135, that's between 90 and 180. So we can rotate it to, it's going to be about right here. And then we want to put our direction of rotation in that. We want the positive direction. So that's 135 degrees. So it would end, the terminal side would end in quadrant 2. All right, so number 2, negative 200 degrees. So negative 200 is going to fall between 180 and 270 in the negative side. So there's our initial side. And so if we rotate in the negative direction, okay, there's negative 180, and we have to go a little bit more. All right, so that's negative 200 degrees. And that, again, falls in quadrant 2. So the quadrants aren't going to rotate in opposite directions. They stay quadrants 1, 2, 3, and 4 going clockwise always. All right, positive 450. So 450, that's bigger than 1 revolution, bigger than 360 degrees. All right, so again, we take our initial side on the positive x-axis. Now, if you want to know how much bigger 450 is from 1 complete revolution, just subtract 450 and 360. So that's 90 degrees. So we're going to go in the positive direction, 1 complete revolution. Okay, that's 360, and then we're going to stop it at another 90. So we do what's called concentric circles. So we start small and get bigger and bigger and bigger to show the amount of rotations. So this is 1 complete revolution plus another quarter, plus another 90 degrees. All right, so let's go ahead and do these other ones. Negative 270. All right, so that's going to be negative 180, negative 270, okay, negative direction, positive 100 degrees, so that's a little bit bigger than 90. Negative 180. Got to make sure that we show that we went in the negative direction. Okay, negative 150. So that's between negative 90 and negative 180. Let's put this about right there. Positive 720. Now 720, that is 2 complete revolutions. All right, so we're going to start here. We're going to go in the positive direction, 2 complete revolutions. So that's 360, and then that's 720. Okay, again, we start and end at the same spot. All right, let's see, negative 30. All right, so we are on the initial side, and then we're just going to go down 30 degrees. Something close to that. Again, put your direction arrow that you went in the negative direction. All right, coterminal angles. So coterminal angles are angles that share the same terminal side. So they start and end at the same spot, but their angles are different. Okay, so what would that look like? All right, so here's our initial side. So let's say we go in the positive direction this way. And so we could say that's about 100, let's say it's 120 degrees positive. Well, we can create another angle that starts at that same spot and ends at that same spot. All we have to do is go in the negative direction. And that would be a negative 240 degrees. All right, so we say that the negative 240 degrees and positive 120 are coterminal angles. Now we could get another coterminal angle. So use green. All right, so I could do something like this. So I could do a full revolution, 360 degrees, plus another 120. Right, so 360 plus 120, that'd be 480 degrees. So we could say that 480 degrees is also coterminal to 120 and negative 240 because they both are, all three angles start and end at the same spot. All right, so how do we find coterminal angles? Well, all we have to do is take the measure of the angle they give us, so we'll just call it measure of the angle, and we're going to add and we're going to subtract 360 degrees. All right, that's how they differ. They're multiples of 360 degrees. So if we have one angle and we add 360, we can get a coterminal angle. And if we have an angle, we could subtract 360 and we get a coterminal angle. Now you can do this as many times as you need to, so it doesn't just have to be done once or twice. You could do it multiple times. So you could have a really, I guess, big negative angle. So let's say you had negative 1,000. Well, if you want to find a positive coterminal angle, by adding 360 degrees one time isn't going to get you a positive angle. So you'd have to do it another time and another time. So you'd have to keep adding 360 until you get it to be a positive angle, if that's what the question was asking. Oh, they said let's look at 130. We'll change it to 120. All right, didn't even see that. All right, so let's go ahead and do these 4 questions. It says find 2 coterminal angles. We want one positive, one negative for each of the following. So given a 60-degree angle, so we start with the angle they give us. We're going to add and we're going to subtract 360 degrees. So if we add 360, we're going to get a positive 420. And if we subtract 360, we're going to get negative 300 degrees. So we say that 60, 420, and negative 300 are all coterminal angles to each other. They all start and end at the same spot. All right, 210. We're going to add, and then we're going to subtract 360 degrees. So if we add, that's going to get us 570. And if we subtract, looks like it's negative 150. Right, again, 210, 570, negative 150 are all coterminal angles. All right, 390. I'm going to add and subtract 360. All right, so 390 plus 360 is going to be 750. If we take 390 minus 360, that's going to get us positive 30. So that's another positive angle. So if we were asked to find a positive and a negative, we could list 750 or we could also list 30, either one. But we haven't found a negative one. So we're going to take that 30 degrees now and subtract off another 360, another rotation. And so then we get negative 330 degrees. All right, so we found a positive one. We actually found two positive ones, and then we found a negative one. All right, so given 390, 750 and 30 are both positive ones. We could list either one, and then negative 330 is a negative one. If we wanted another negative, we would subtract another 360. All right, so negative 300 degrees is the angle they give us. Let's add and subtract 360. All right, so negative 300 plus 360 is positive 60 degrees. There's a positive one. And then we could take negative 300 and subtract 360. That's going to get us negative 660. All right, and then the last thing we're going to talk about today is what's called reference angles. So reference angles are acute angles, so angles that are less than 90 degrees, so they're angles between 0 and 90, so they have to be positive. It's formed by the terminal side of the angle and the horizontal axis. So wherever the angle stops, we want to find out what is the angle between that angle, where it stops, and the x-axis, the horizontal axis. So you can see if the angle falls in the first diagram, if the angle falls in quadrant 2, the reference angle is going to be this angle right here. That's the angle that we want to try to find. If the angle falls in quadrant 1, then it'll be its own angle. Okay, so that's the angle to the x-axis. If the angle falls in quadrant 3, then we have to kind of go backwards because this is the reference angle right there. And then if the angle falls in quadrant 4, then the reference angle to get to the x-axis would be over here. All right, so those angles will get you an angle that's called the reference angle that's between 0 and 90 degrees in measure. All right, so let's go ahead and find the reference angle for each of these. So the easiest thing to do is kind of sketch the graph out so you can see where it falls and then what the angle would be to get to the x-axis. So 150 degree angle is going to fall in quadrant 2. All right, so here's 150 degrees, it's positive. So the reference angle is going to occur when it goes to the x-axis. It's that angle right there. So we want to know is how much more do we have to go to get to the x-axis. So if we're already at 150 and we know the x-axis to get all the way over is 180 degrees, then we would need to go to 30 degrees more. So the reference angle to 150 degrees would be 30 degrees. All right, 15, 210. So 210 is more than 180, so it's going to fall in quadrant 3. All right, so here's 210. So our reference angle is right here to the x-axis. So this angle right here, to get it, we're going to take 210 and subtract off 180 degrees, and that would be 30 degrees. All right, and so we can see that that's 180 degrees, half a circle, and then we would add another 30 degrees. That would get us our 210. All right, so we say 30 degrees is the reference angle to 210. All right, 300 degrees. So 300 is going to fall in quadrant 4. It's a little bit more than 270. And so this is 300 degrees. So our reference angle is, again, to the x-axis. So it's this angle right here. So we have to, if we're at 300 and we know one complete revolution to get back to the x-axis is going to be 360, we subtract those two, the reference angle is going to be 60 degrees because 300 plus 60 is 360. All right, and then 17, this is the last one, negative 405. So we have to go in the negative direction this time, 405 degrees. So we know 360 is one revolution, so we subtract those two, and we have to go another 45. All right, so we went 360 plus another 45 is negative 405. So our reference angle is going to occur right here. So you just have to figure out, well, how much more do we have to add from one revolution? Well, we had to add another 45 degrees. All right, so again, reference angles have to be positive between 0 and 90. And so on this one, we have to say 45 degrees, and it's positive. All right, and that's it.